Hello, my name is Sinwoo Kim, and this is my report for Lab 1. This report will consist of the introduction, principles, experiment, computational model, results, and the conclusion. The purpose of this lab is to prepare two pieces of charged Scotch tape and observe their interactions with each other and with other charged objects to estimate the amount of excess charge on each piece of tape. The point charge model estimated the charge to be 1.317 times 10 to the negative 8 coulombs, and the line charge model estimated it to be 3.01 times 10 to the negative 8 coulombs. The principles we will be using in this lab today include Newton's second law, which states that net force is equal to mass times acceleration, so if there's no acceleration observed, net force must equal 0. Also, the force of gravity near Earth's surface is minus mg in the y direction, and Coulomb's law to calculate electric force is K, Coulomb's constant, times the first charge times the second charge, all divided by r squared. To conduct the experiment, I first charged two pieces of tape by using contact, and then I made sure that they were charged by bringing my hand close and see if it was attracted. Then, I floated one tape on top of another and measured the distance at which it started to float. To estimate the charge with the point charge model, I first inputted the initial conditions on the left side, which are the length and width of each piece of tape in meters, the mass of the pieces of tape in kilograms, and the distance at which tape B began to float above tape A. For the calculations, I calculated the force of gravity, and I was able to calculate the electric force, which is equal and opposite in magnitude when F net equals 0 due to Newton's second law, and then I estimated the charge by manipulating Coulomb's law. This is the output of the model, with the red dot being tape B and the blue dot being tape A. The green arrow depicts the force of gravity, and the orange arrow depicts the electric force that cancels it out. The assumptions for this model are that each tape has all its charge located at a single point in its center, and each piece of tape has the same net charge. Now, to estimate the charge using the line charge model, I first inputted the initial condition, which was just the mass of each piece of tape, same as before, and then I started with the charge estimate from the last model, and then it took a bit of trial and error, and that was the final value that I got. For the calculations, we had to calculate the electric field on tape B due to tape A, and then multiply that by charge to get the electric force on tape B by tape A. This is the model with each piece of tape depicted as a line. The yellow arrows depict the electric field from tape A, and the white arrow is the electric force, and the green arrow is the gravitational force. As you can see, their magnitudes differ slightly, and I tweaked the estimated charge until I could get them as close as I could. And the assumption for this model is that each piece of tape has the same net charge. Now we will cover possible sources of error. The first one is that charge can be very quickly lost when the tape is in a humid environment or is handled too much. Also, charges may be unequally distributed along a piece of tape, which our model does not account for, and estimating the charge using the line charge model required a bit of trial and error, and I was not able to get the magnitudes exactly close. Now we will cover some questions about our experiment. What if the electrons were positive and protons were negative? What would change about the observations made with the tapes and other charged objects? If the signs of the charges were swapped, the floating tape experiment would still work. The two pieces of tape repel each other and float because they had the same charge, which is positive, but if they were both negatively charged, they would still repel. It's just that their charge would be negative. However, when interacting with a negatively charged object, like a pen that has been rubbed on cloth, each piece of tape would repel from it rather than attract as it did before. Why? Compare the charge estimate from using the point charge model versus the line charge model. Why are they different, and which one is closer to the real value? The estimate using the point charge model is 1.317 times 10 to the negative 8 coulombs, and with the line charge model, it is 3.01 times 10 to the negative 8 coulombs. They are different because they calculate the electric field on tape B in different ways. The line charges model is likely closer to the real value because, in reality, our tape is not a single point.